In this video, I will introduce the three trig functions, sine, cosine, and tangent. So when you see sin, you should go ahead and say sine, because this is short for sine. Don't say sin. This is short for cosine. And tan is short for tangent. So these are the definitions, but to understand the definitions, we need to glance at a right triangle. These definitions apply to a right triangle. So, of course, the hypotenuse is always going to be across from the 90-degree angle. These other two words, opposite and adjacent, depend on what angle you're talking about. So, assume we're talking about this angle where I have this Greek letter theta right here. The side that is across from the angle is the opposite side. So opposite means across from. The side that is really close to the angle is the adjacent side. All right, so that's what you should do when you're solving these problems. Start by identifying the hypotenuse, and then the opposite side will be across from the angle. The adjacent side will be close to the angle. Just pull back these arrows. All right, now with that in mind, the sine of the angle will be the opposite side divided by the hypotenuse. The cosine is adjacent side divided by the hypotenuse, and the tangent of the angle is the opposite divided by the adjacent. Sometimes we abbreviate those definitions using the word SOHCAHTOA, and you can see if you break it down, the SO part is standing for the definition of sine. Sine is opposite over hypotenuse. The CA part, cosine, is adjacent over hypotenuse, and TOA, tangent, is opposite over adjacent. So if you can remember the acronym SOHCAHTOA, it will help you remember the three definitions. So let's practice those. We need to find each trig ratio, and we're going to express our answer as a reduced fraction. So it's a good idea to start off by labeling the hypotenuse. So on this triangle, I see the right angle is here. So that makes this 41 the hypotenuse. Whoa, that's a yellow. All right, so this is the hypotenuse. Now we need to focus on the angle that we're talking about, the sine of angle Q. So let's circle that angle Q and draw an arrow across from angle Q. This will be the opposite leg. The other one that is close by is the adjacent leg. So, sine is opposite over hypotenuse. Okay, if we use this SOHCAHTOA to help us remember, this first part is sine is opposite over hypotenuse. So that's going to be 9 over 41. Okay, and that does not reduce, so that's the answer. For problem number 2, the hypotenuse is the 25 because it is across from the 90-degree angle. Now, we're doing the cosine of angle P, so let's circle angle P and draw an arrow. So that will be opposite. So the other one is adjacent. Okay, cosine is adjacent over hypotenuse. So that's going to be 20 over 25. All right, both of these are divisible by 5. So that's going to reduce down to 4 over 5. For number 3, the hypotenuse is the 39 because it's across from the 90-degree angle. We're doing the tangent of angle L, so let's circle that and draw an arrow across from it, this will be the opposite leg, the opposite side. The other one will be adjacent. All right, tangent is opposite over adjacent. So that's going to be 36 over 15. Both of these are divisible by 3. So that's going to make 12 over 5. Okay, I feel like I should write SOHCAHTOA, leave that somewhere on the screen at all times. SOHCAHTOA. Make it bold. Okay. All right, I guess we're just continuing the same thing. So this 41 is the hypotenuse because it's across from the 90-degree angle. We're doing the sine of angle S, so let's circle angle S and draw an arrow going across from it. This will be the opposite leg. The other leg is the adjacent leg. So sine is opposite over hypotenuse. So that's going to be 40 over 41. All right, 41 is a prime number, so I know that will not reduce. Number 5, the 25 is the hypotenuse. It is across from the 90-degree angle. We're doing the cosine of Q. So let's circle Q and draw an arrow across from Q. This will be the opposite leg. The other one will be adjacent. Cosine is adjacent over hypotenuse, so that's going to be 15 over 25. Both of these are divisible by 5, so that's going to give me 3 over 5 for the reduced answer. For number 6, I see that the hypotenuse is 39 because it's across from the 90-degree angle. We're doing the tangent of angle N, so let's circle that and draw an arrow across from N. This will be the opposite leg. The other will be the adjacent. Now, tangent is opposite over adjacent, so that's going to give us 15 over 36. Both of these are divisible by 5. No, that's not what I meant. Both of these are divisible by 3. So that's going to give us 5 over 12 for the reduced answer. For number 7, we have to do this problem in 2 stages. First, we have to find the missing side. So I'm just going to temporarily put an X right here. And so when we have 2 out of 3 sides and I want to find the third one, we use the Pythagorean Theorem. Leg squared plus leg squared equals hypotenuse squared. So that's going to be x squared plus 22 squared is equal to 122 squared. Of course, the 122 is the hypotenuse, which I might as well label now. And when you do the Pythagorean theorem, the hypotenuse has to be the one over here by itself. Now, I'm going to grab a calculator to help me out with this a little bit. So I'm ready. So I've got x squared plus. Now, 22 squared is 484. And let's see, I'm typing in 122 squared is 14,884. So now we have to subtract 484 from both sides. 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 Okay, so this should be 14,400. All right, now we have to take the square root of both sides. So back to my calculator. Square root of 14,400. And that turns out to be 120. So that is the missing side. So now I'm going to go back and go ahead and substitute that in where it belongs. So this is 120. All right, now it's time to do the stuff on the right-hand side. Okay, so we have the hypotenuse labeled. The next several problems all involve angle A. So for now, I'm going to circle angle A, and I'm going to draw an arrow away from it, and that will point to the opposite leg. The other leg is the adjacent leg. So sine is opposite over hypotenuse. So that's going to be 120 over 122. All right, so I'm going to use my calculator to just cheat and reduce this. So 120 over 122. So that reduces down to 60 over 61. All right, and you can just type this in your calculator and it will reduce it for you. I'm using a TI-30 XS multi-view. And normally I could show you that on the screen, but the tech people upgraded my computer and they haven't put the calculator software on my computer yet. Anyway, cosine is adjacent over hypotenuse, so that'll be 22 over 122. Okay, well, both of these are even. I'm going to try to do this by hand. Both of these are even, so that means they're both divisible by 2. Can you guys hear the rain on this microphone? So that's going to be 11 divided by, so it'll be 61. Okay, 11 over 61. Boom. All right, tangent of A. Tangent is opposite over adjacent. So that's going to be 120 over 22. Right? Okay. And again, both of these are divisible by 2. So that's going to be 60 over 11. All right. Okay, this says sine of A again, but I'm sure that they meant sine of B. So that's what I'm going to do. All right, let's do sine of B instead. Okay, so sine of B. So we need to change the angle of focus now that we're talking about angle B. So let's circle angle B and draw the arrow. All right, so that's going to change which is opposite and which is adjacent. So now the 22 becomes the opposite leg because we're talking about angle B. The 120 is now the adjacent leg. Okay, so Sine is opposite over hypotenuse. So that'll be 22 over 122. All right, so both of these are divisible by 2. So that's going to be 11 over 61. And then cosine of b. Cosine is adjacent over hypotenuse, so that's 120 over 122. All right, if I divide both of these by 2, I'm going to get 60 over 61. All right, that looks like 66. Okay, and finally tangent of b. And of course, tangent is opposite over adjacent. So that's going to be 22 over 120. If I divide both of these by 2, I'm going to get 11 over 60. Number 8 is another one that I have to do in stages. So first we are supposed to label the sides of the triangle so that the cosine of 60 is 1 over 2. Let me bring my SOHCAHTOA back down. So keep in mind that we know that the definition of cosine is, well, let's cheat. Cosine is adjacent over hypotenuse. So that means that this numerator, the number 1, has to be the adjacent leg, and the 2 has to be the hypotenuse. So keep that in mind. Now, the hypotenuse is always across from the 90-degree angle, so we should always list that first. So we know that this side over here is the hypotenuse. Okay, now, the angle that we're dealing with is this 60. If I circle that angle and draw an arrow across from it, that tells us that this side is the opposite leg. That means the other leg is the adjacent leg. So right there, that's going to allow me to fill in the 1 and the 2 because the adjacent leg has to be 1. So I can put a 1 on this side of the triangle. I'll change colors. So I can go ahead and put a 1 over here. Boom. The 2 is the hypotenuse. So I can go ahead and put a 2 right there. So I'm only missing the opposite leg. All right, so it says find the missing side length and the missing angle measure. Label them both in the diagram. So let's find the missing side length first. Okay, so this opposite side, I'll call it x. And I can use the Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared will become x squared plus 1 squared is equal to 2 squared. So that's going to give me x squared plus 1 is equal to 4. And if we subtract 1 from both sides, that gives me x squared is equal to 3. Now, if I take the square root of both sides, I can't take the square root of 3 without making it into a decimal. So for now, I'm going to just leave it as the square root of 3. Okay, so this missing side over here is the square root of 3, or radical 3. So I'm now going to go ahead and replace that with radical 3. Okay, great. Now we are also supposed to find the missing angle measure, and we're supposed to label that. Well, we have a 90 and we have a 60. So we're trying to find this missing angle over here. So we're going to use the fact that all of the angles have to add up to 180. So now here's the thing. If you start from 180 and you subtract 90, all right, so far you have 90 left. So once I take away the 90, that means I have 90 degrees left to be shared between these remaining two angles. So a shortcut, instead of always dealing with 180, during this unit, we're going to be dealing with right triangles over and over and over again. So the shortcut is to realize that since we already have 90 degrees right here, that will always leave 90 degrees for the other two. So the other two angles always have to add up to 90. All right, so I have 90 degrees that must be shared between this angle and this angle. So instead of subtracting two angles from 180, it's going to be quicker to subtract one angle from 90, all right, since these have to add up to 90. So the quicker thing to do is just to do 90 minus 60. And that is going to give us this angle right here. And of course, that is 30 degrees. All right, so from now on, I'm not going to add up all of the angles and subtract from 180. As soon as I see that I have a right triangle, I'm just going to subtract the one angle from 90 to get the other angle. Let's do the same thing for number 9. Tangent. We know that tangent is opposite over adjacent. That means the 24 must be opposite and the 7 must be adjacent. Okay, let's start with the hypotenuse, which is always across from the 90-degree angle. So we know that this is the hypotenuse right here. Now, the angle is the 73.7. So I'm going to circle the angle and draw an arrow away from it because that will indicate the opposite side. The other side is going to be the adjacent side. All right, so now we can fill in the opposite and the adjacent. All right, the 24 and the 7. Okay, so the opposite is 24. So I can put 24 right here. And the adjacent is 7. So that means this side right here will be 7. That just leaves the hypotenuse. So I'm going to call that x for right now, and I'm going to use the Pythagorean Theorem to find it. So it's going to be a squared plus b squared equals c squared. Okay, the hypotenuse always has to go over here by itself. Now I'm consulting my calculator right now. 24 squared is 576. Okay, plus 49 is equal to x squared. So that's going to make 625 is equal to x squared. So then it's time to do the square root of both sides, and I believe that this is 25. Okay, so the hypotenuse is 25, so I can go ahead and fill that in. All right, so we found the missing side length. Now, the missing angle, we have now learned we don't have to deal with 180. We have 90 degrees here. That means that the other two angles have to add up to 90. So the easiest thing to do is simply to do 90 minus 73.7. And that is 16.3. So that's it for number 9. All right, last one. Sine of 67.4 degrees is approximately 12 over 13. Sine is opposite over hypotenuse. So we know that this 12 is the opposite leg, and we know that the 13 is the hypotenuse. The hypotenuse is always across from the 90-degree angle. So that means this is going to be the hypotenuse right here. Now, opposite and adjacent depend on which angle you're talking about. So circle the angle and draw an arrow across from the angle, and that will tell you the opposite leg. The other leg is adjacent. Okay, now, since we know that 12 is opposite, then we know that the 12 is this side right here. We know that 13 is the hypotenuse, so we know the 13 goes right here. We need to find the missing side, and we're going to use the Pythagorean theorem for that. So when you do your a squared plus b squared equals c squared, just remember to put the hypotenuse always in the c position over here by itself. So this will be x squared plus 144 is equal to 169. And then if we subtract 144 from both sides, then we get x squared is equal to 25. So when we take the square root of both sides, we find out that x is equal to 5. So that tells us the missing side is 5. So I'm just going to erase the x and put 5 in its place. All right, now we have all the sides. Now we just need this one missing angle. And as we've discussed, since we already have a 90-degree angle right here, that means the other two angles must add up to 90 degrees. So the quickest way to find this angle right here is to do 90 minus 67.4. And while I was off camera, they installed my calculator. So we can do it now. So 90 minus 67.4 is 22.6. All right, so we have 22.6 degrees right here.